Hi there, and welcome to this lesson. In this lesson, we'll be learning about sequences and series, okay? And we'll do a brief introduction, then we'll learn about arithmetic progressions, and finally, we'll learn about geometric progressions, okay? And as the lesson progresses, if you have any issues, if anything comes off as unclear, please feel free to get in touch. You can do so via phone, WhatsApp, Skype, or Facebook, and we would be happy to help. Alright, you can also visit our website. We do have a lot of exciting features on there. And yeah, let's jump right into the lesson. So sequences and series, we start off with a brief introduction. Okay, introduction to sequences and series. So a sequence is a set of numbers arranged in a manner in which they follow one another, okay, with each number obtained from the preceding number following a given relationship. For example, you could have 3, 10, 17, 24, 31, 38, and so on. And basically what you notice is you have the following number obtained from the number before it, i.e. you have 10 obtained from 3 by adding 7, okay, following a given relationship. And the same way you have 17 obtained from 10 by adding 7. You keep adding 7 as the sequence progresses, okay? And in the same way, you have 4, 20, 100, 500, 2500. You have 20 obtained from 4 by multiplying by 5, and you have 100 obtained from 20 multiplying by 5 as well. So it's a fixed relationship as the sequence progresses, okay? Now there are two major types of sequences, okay, and these are the arithmetic sequence and the geometric sequence. And I'll tell you that the two examples we have, the first example, 3, 10, 17, 24, is an arithmetic sequence, and 4, 20, 100, 500 is a geometric sequence. So let's understand what arithmetic sequences or arithmetic progressions are. Okay, so we start with arithmetic progressions. An arithmetic progression is a sequence that progresses using a difference. Okay, for example, you have 3, 5, 7, 9, and so on. You notice we're adding something as the sequence progresses. Okay, and in this case we're adding 2. So we start off with 3, and we have 3 plus 2 equals 5. And we have 5 plus 2 equals 7, 7 plus 2 equals 9, and so on. Okay, now we can find the value of a given term in an arithmetic sequence using the formula Tn equals a plus n minus 1d, okay, where a is the first term of the sequence and d is the common difference of the sequence, i.e. the number that we're adding as the sequence progresses, and n is the nth term of the sequence. For example, if I ask you to find the 10th term of the sequence, n would be 10. Okay, we can also find the sum of all the terms in an arithmetic sequence up to a given term using the formula Sn equals n over 2 multiplying 2a plus n minus 1d. Okay, and similarly, n is the term, the given term. For example, if I ask you to find the sum of all the terms of an arithmetic sequence up to the 7th term, n would be 7, okay, and a is the first term of the sequence and d is the common difference, okay. And let's talk now about geometric progressions. Now, a geometric progression is a progression that progresses using a ratio. Okay, so an arithmetic progression progresses using a difference. A geometric progression progresses using a ratio, okay, using a multiplier. All right, and basically we have something like 3, 6, 12, 24, and so on. What we have here is we have a geometric progression progressing with a ratio of 2. Okay, so we start off with 3 and we multiply by 2 to get 6, we multiply by 2 to get 12, we multiply by 2 to get 24, and so on. And in the same way, we can find the value of a given term in a geometric sequence using the formula Tn equals arn minus 1, okay, where n is the term we're looking for, and a is the first term of the sequence, and r is the common ratio, i.e. the number that will multiply with as the sequence progresses. And similarly, we can find the sum of all the terms in a geometric sequence up to a given term using the formula Sn equals a 1 minus r to the power of n divided by 1 minus r. Okay, so that's a bit about sequences and series, and I think we can go ahead now and solve an example. Okay, so example 1. And example 1 says find the 15th term of the arithmetic progression 5, 8, 11, and 14. Okay, and to do this, the first thing we need to do, we need to identify the relevant formula. Okay, so we've been asked to find a term of an arithmetic progression, and the formula we need to use here is we need to use Tn equals a plus n minus 1d. Okay, so we have Tn equals a plus n minus 1d. Okay, and then the next thing we need to do is we need to identify our parameters. Okay, so we need to know what a is, what n is, and what d is. So we have that in this case a is 5, okay, because 5 is the first term. The first term of this progression is 5, so we have that a is 5, and then we have that n is 15 because we've been asked to find the 15th term of the progression. Okay, and then we have that d. To find d, basically we're looking for the difference. D is 8 minus 5, which is 3, or 11 minus 8, which is also 3, or 14 minus 11, which is also 3. Okay, so the common relationship, the common difference. Okay, so we have a, we have n, and we have d. And the next thing we want to do is we basically want to put all of that into our formula. So we have that Tn, our formula is Tn equals a plus n minus 1d, and basically we have that T15 equals 5 plus 15 minus 1 times 3. Okay, because a is 5, n is 15, and d is 3. Okay, and T15, because we're looking for the 15th term, equals 5 plus 14 times 3. Have that T15 equals 5 plus 42, and finally we have our answer. T15 is 47. Okay, so if you decide to write out this arithmetic progression, okay, if you continue to write this out up until the 15th term, okay, so this is our first term. Our first term is 5, second term is 8, third term is 11, fourth term is 15. If you continued adding 3 up until the 15th term, you will arrive at 47 as your 15th term. Okay, and that is how you solve for a given term in an arithmetic progression. Okay, let's move on. Okay, so let's bring up another example. So example 2. And example 2 says if the third and eighth terms of an AP, okay, are 1 and minus 9 respectively, find the value of the first term and common difference. Okay, in this case we're doing the reverse. All right, we've been given two terms of an AP. We've been given the third term and the eighth term of an AP, and we've been asked to find the first term and common difference. Okay, in the first example we're given the term and common difference and asked to find a term. We're given the first term and common difference and asked to find a term in the arithmetic progression. In this case we've been given two terms and we've been asked to find the first term and common difference. Okay, let's jump right into that. And the first thing we need to do here, we need to identify a formula. Okay, we have that Tn equals a plus n minus 1d. Okay, and the next thing we do is we have that T3, substituting your parameter into the equation. You have that T3 is a plus 3 minus 1d, okay, which is a plus 2d. Okay, let's understand that. So T3 we have that Tn equals a plus n minus 1d, which tells us that T3 would be a is the first term, plus 3 minus 1d, okay, because n in this case is 3, which tells us that T3 is a plus 2d, all right. And then T7, that's T8 is a plus 8 minus 1d, okay. So basically we have a plus 7d. We simply substitute 8 into the formula here, all right. And then the next thing we need to do is we have a plus 2d equals 1, because we've been told that the third term is 1, okay. So T3 equals a plus 2d equals 1, okay. And T8 equals a plus 7d, which is minus 9, okay. And basically we label this as equations 1 and equations 2. Now we have two simultaneous equations with variables a and d, and we simply need to solve these simultaneous equations to obtain our answers for a and d, i.e. the first term and the common difference. And the best way to go about doing this is to solve this set of simultaneous equations using the elimination method. Okay, it's the easiest method for solving this because we can eliminate a very easily, and we can do so by subtracting equation 1 from equation 2. Okay, and if we do that, we have a plus 7d minus a plus 2d, which would equal minus 9 minus 1. Okay, let's look at that. So two equations 1 and 2, and we basically subtracted this equation. We subtract equation 1 from equation 2, so we'll have equation 1, a plus 7d minus a plus 2d equals minus 9 minus 1, okay, minus 9 minus 1. And basically what we have is we have 5d. When we solve that out, we have that 5d equals minus 10, which will tell us that d is minus 2. So the common difference in this question is minus 2. Again, now to solve for the first term, we basically substitute minus 2 for d in any of the equations here. Okay, and we have that a plus 2d equals 1, a equals 1 minus 2d, and you have all of that, and finally you'd have that a equals 5, and that is how you solve that. Very simple. It's quite lengthy, but it's actually very simple, very straightforward. You basically just need to obtain two equations to represent the third term and the eighth term, okay. And once you've done that, all you have to do is just solve simultaneously, okay, because we basically just have that. So let's jump into the next question. Example 3. And example 3 says find the sum of the first 12 terms of an AP 3, 5.5, 8, 10.5. Okay, what's the common difference here? The common difference would be 5.5 minus 3, which would give us 2.5. But let's jump into the question. Okay, let's solve it out. We've been asked to find the sum, okay, of the first 12 terms, that is S12, and we need to identify the relevant formula here, which is Sn, the sum of an AP. Sn equals n over 2, 2a plus n minus 1d. Okay, you have to remember all these formulas. Okay, there are just 4 formulas you need to remember here: the formula for the term of an AP, the formula for the sum of an AP, and the formula for finding the value of a term of a GP, and the formula for finding the sum of a GP. So this is the formula for finding the sum of an AP, and basically we identify our parameters. Okay, so we have the n, in this case is 12, because we've been told to solve for the sum of the first 12 terms of the AP. And then we have that a which is our first term, equals 3, and we have that d as our common ratio, equals 2.5. And now what we need to do is just simply impute our parameters into the formula, and basically we have that S12 equals 12 over 2 multiplied by 2 times 3 plus 12 minus 1 multiplied by 2.5. And if you solve that out, you would have that S12 is 201. So basically, if I wrote down the first 12 terms of this arithmetic progression, i.e. if I continue this progression here, if I continue this 13, 15 and a half and so on, basically if I wrote this down to the 12th term and I added all the numbers together, I would get 201. Okay, so that is how it works. Now let's move on to the next example. So we have example 4. And example 4 says find the 10th term of a GP with the first term 3 and common ratio 2. Okay, so we're talking about GPs now. Okay, we're done with arithmetic progressions. Now we're talking geometric progressions, and if you remember, geometric progressions progress with a ratio. Okay, and we've been asked to find the 10th term of a GP if the first term is 3 and the common ratio is 2. So first thing we need to do, identify a formula, and the formula for finding the value of a term of a geometric progression is Tn equals ar to the power of n minus 1. Okay, so that's the formula we need to use in this case. And the next thing we do is we identify our parameters. So in this case we have that a is 3 because our first term is 3. We have a common ratio r is as 2. Okay, and then we have n, the term we've been asked to find, as 10. Okay, we've been asked to find the 10th term, and then all we need to do is we need to substitute those values into the formula, and we have that T10 equals 3 times 2 to the power of 10 minus 1, which will give you that T10 equals 3 times 2 to the power of 9. And basically you solve all that out, it will tell you that T10 is 1536. These are actually ridiculously easy. Okay, once you know the formula, you know the parameters, you basically just substitute your values into the formula. Okay, let's move on to the next example. So we have example 5, and example 5 says, okay, so just like we had for the AP, we've been given 2 terms of a GP and we've been asked to find the common ratio. Okay, and it says if the second and sixth term of a GP are 8 over 9 and 4.5 respectively, find the common ratio. Okay, so how do we go about solving this? First thing we need to do is we need to identify the relevant formula. Okay, so we're working with terms of a GP. We have that Tn equals arn minus 1. Okay, and then we have that T2, the second term, is ar2 to the power of 2 minus 1, okay, which is ar to the power of 1, which is simply ar. Okay, so that is a representation for the second term. Okay, we're trying to draw up 2 simultaneous equations in the same manner we did for the arithmetic progression question. Okay, so for the second term we have that T2 equals ar to the power of 2 minus 1, which is ar. Okay, and then T6 is ar to the power of 6 minus 1, which is ar5. Okay, next thing we want to do is we've been told that the second term, which is ar, is 8 over 9. Okay, and we've also been told that the sixth term, which is ar to the power of 5, is 4.5. Okay, and all we have to do, basically we have this as equation 1 and equation 2, and what we need to do now is we need to solve simultaneously. Okay, and similarly to the question on arithmetic progressions, we're going to solve this using the elimination method, but not quite in the same manner. Okay, because instead of subtracting like we did before, we're going to divide. Okay, so what we have is we have equation 2 divided by equation 1, i.e. ar5 divided by ar equals 4.5 divided by 8 over 9. And when you solve that out, you'd have that ar because basically a would cancel a, and what you have is r5 divided by r, which give you r to the power 4, and this would equal 4 1/2 divided by 8/9, and it will give you 9/2 multiplied by 9/8. And when you solve that out, you find the fourth root of both sides. You'd find that r equals 3/2, which would be the common ratio of this geometric progression. Okay, let's move on to the next question. Now, example 6. Now, for example 6, we've been asked to find the sum of the first 5 terms of a GP with the first term 3 and common ratio 2. Okay, so first 5 terms of a GP, the sum of the first 5 terms, so the sum up until the 5th term of a GP with the first term is 3 and the common ratio is 2. Okay, so the first thing we need to do here is we need to identify a formula. And the formula for finding the sum of a GP is a multiplied by r1 minus r to the power of n divided by 1 minus r. Okay, and then we'll identify our parameters. We have that a equals 3, r equals 2, and n equals 5. And the next thing we need to do is we simply need to substitute, impute those parameters into our formula, and we have a formula. We put all our parameters in, we solve all of that out, and basically we have that the sum up to the 5th term of the GP with first term 3 and common ratio 2 is 93. And that is how you solve for the sum of the terms of a GP. Okay, and that would be the end. We'll stop here of this lesson. And I think that's pretty much all you need to know about sequences and series. Okay, and yeah, bye for now.